Joining in on January's free Micro-Vu webinar. My name is Dustin, and in the chat is Dan. We are part of the metrology team here at ATI. If you haven't met us before, we do the Micro-Vu trainings, schema manager trainings. We've done how we do inspection services, really anything that you guys need help with the Micro-Vus or inspection, you guys can come to us for some of that help. So I want to jump into it today. We got a lot of stuff to cover. First thing I want to talk about is last year we hosted probably around 9 to 10 webinars covering tons of different topics, everything from general tips and tricks. So that was 1.0. Today is going to be the 2.0 tips and tricks. So just a couple things to help you guys be more organized and program faster and more efficiently. We talk about getting organized before you even start measuring. Offline programming, so Micro-Vu does have an offline programming seat that you are able to program from home, your office, off of the machine with DXFs to get all the tolerancing, renaming, all the dimensions out of the way before putting the part actually on there. If you want to know more about that, please contact us and we can see if it's a good application for you. Setting systems, we talked about that last year. We're going to talk more about that this year. And in today's webinar, we talked about GD&T, improving and expediting your process, building the right touch probe if your machine has a touch probe attachment. Talked for a full hour on true position. And probably this year, we're going to dive deeper into more GD&T. We talked about lighting, all the different lighting options that you have that are on your Micro-Vu to be able to help you get more repeatable and accurate measurements. And then some functional measurements. So if you're talking to a customer that has calipers or height gauges, but not a vision system, how your measurements can relate to their measurements on there. So to kick this off, I would like to throw this out there for you guys to join the chat. We want to know who has the longest or most features in a program. This program that we have had 10,000 diameters on 2 sides and some cylinders that we had to measure, and we ended up getting 5,243 features in this program. So I want you guys to jump on the chat box, say hello to Dan. If you have any questions, you can talk to him, but if you know off the top of your head what your longest or most features program is, pop it in there, or you can email us afterwards and let us know. Just really interesting to see how long programs are running, how you guys are using the Micro-Vu, so we can share it to the rest of the people that are on these webinars here. So next webinar that we do, I'll show or list off the top 3 longest programs that I heard from. I know Dan's done some programs in the past that has everywhere from 5,000 to 6,000 features on there. And then, you know, we have some programs that have 2 features on there. But we just want to know what the longest program you guys have. So if you don't know where the chat box is, depending on how you opened up WebEx today, you can either go on your phone and it's in the top, and on your screen it's in the bottom, or the top. You might have to hover your mouse over the bottom or the top screen to see it pop up for the chat. So jump in there. If you guys know how long your program is, throw it in there, and it'd be fun to share and see what that kind of thing is. And if there's anything else that you guys want to know from all the other customers throughout the Midwest, that how they're programming, I love to pop these questions in here just to get conversation going between all you, because learning from other users could be very useful. So a couple things, just I want to get the business out of the way before we get into the what you guys are here for. I want to let everybody know that our inspection services here, we're able to do in-house first article inspections, PPAPs, anything you see listed here and more. If you guys are having difficulties with your inspection or you need a third party, you're able to send us a blueprint and a quantity, and we could quote it out for you to get the inspection done for you. We also do testing services like force, tensile, compression, hardness, roundness, flatness, straightness, 2D profile. So if there's anything that you guys can't handle in-house, go ahead and contact Zachary at atiquality.com and we can help you with that project. Also, We do a little reverse engineering. So if you guys have gauges that you don't have prints for, or if you have parts that you don't have prints for, we can help you out there and reverse engineer some parts for you so you can get into production. Again, email Zachary at atiquality.com, or if anything reverse engineering, feel free to email Zachary and Dan at atiquality.com. We also do custom fixtures. So if you guys have, running 100 parts per lot or whatever it might be, or you have a difficult part that you don't have fixturing for, feel free to contact us. We've done a few different fixtures in the past, everything from, multi-part, couple parts here that need touch probes. We've done fixtures over here that have standards like a ring gauge and a height block on there just to verify your machine. Whatever you need, we can handle it. And one thing I forgot to mention before starting in here, I'm actually on our Micro-Vu demo machine in our warehouse today. So if you guys hear any bells go off or shipping happening, just please excuse the distractions back here, and hopefully it's not too distracting for you. But please have patience and grace with me with any noises back here. Another thing that I want to say is we are doing on-site Micro-Vu programming. We always have. I just want to throw it out there that if we have customers that are close to each other, we are able to group them together if your dates are flexible to save you guys money on travel and some training discounts on there. So if you guys are looking for in-person training, feel free to contact us, and we can hopefully, if we have some customers in the same area, we can all pair you guys together to save you guys some money on that training. All right, business out of the way. Last year, we had a lot of good feedback from you guys of what can make these Micro-Vu training webinars better, more beneficial for you. So one thing that I heard was just more structure in them. So I've taken some suggestions from a lot of you that fill out the survey that I send after the webinar. So intro, just this kind of stuff, introing the webinar, what we're going to be talking about. We'll do a quick review of last webinar just to refresh you guys. I'm not going to get into last December one this time. But then number 3, community question, like I said, that I don't see anybody chatting in the chat box of the longest program, but just those kind of questions to get you guys communicating on the chat and just to find out how you guys are doing, fun stuff with your programs, and then specials, like I just said, the business of, any discounts that we have going, any specials that we have going. Want to let you guys know about that. One big suggestion that I absolutely loved was to do a beginner, intermediate, and advanced tip every single webinar of just a random thing of just like, a lot of you may know this, but it's just a beginner tip, intermediate, and advanced, and then that can lead into the main topic. Today's webinar, actually, the main topic, some of the main topic will be a lot of the advanced tip. So if I am doing a demonstration of something, or there's something that's just way over your head, you'll get there the more that you use the software and the machine, and that's why I want to do those intermediate and advanced tips so you guys can advance your skills and get there. And at the very end, we'll leave some time for a Q&A. Even if it goes over 11 and you guys got to get back to work, you can jump off the webinar, but me and Dan will stay on here to answer any questions that you guys may have. All right, so January webinar topics. We got a lot here, and we're going to get through all of it. So like I said, basic, intermediate, and advanced programming tips. We'll get to that. Order of setting up your systems. So a lot of times you might only have one system on a part because it just has one datum structure, but I want to go through showing you the advantages of having a fixture system set up. So in case your fixture moves slightly on your stage, it's able to grab that. And then a part coordinate system, so another system, getting that zeroed in just in case there's any fluctuation in your part. And then we can even set systems to individual features to be able to translate certain features, which will be our advanced tip today. So you'll see that. I'm going to show you some focus point tricks. I saw a lot of people who registered today were saying that they would like to see some focus point tricks, so I'm going to include those, some Z height tricks. And what I'm trying to accomplish with those is to show you guys ways of programming faster. because if you can cut down on your programming time, then you're getting to actually inspecting and running parts, and that's the main goal. And then flip working planes. I've covered slightly a little bit about flip working planes in past webinars, but I want to really show you and spend some time on one today on a radius that I can't see straight down on the camera with at the right angle. So we're gonna do that. A little difficult, and if it's a little, like I said, above your skills, don't worry, you'll get there. And if you have any applications like that, email me and Dan. So Dustin at atiquality.com and Dan at ATI Quality, and we'll be able to help you. Looking at a print, we can decipher the right way to do the program for you. And also, I also do want to mention on that is if you guys have an application that you're just having a really hard time with, I know a lot of us are using Teams, Microsoft Teams, but there's also an application called TeamViewer, which is really nice. It's free. It allows Dan and I to log into your computer and control your machine. So if you're having difficult problems that you can't figure something out, we can get on a call on TeamViewer and be able to help you out. So just know that option's there. It's really nice. So I just saw in the chat box also lighting tips. I have a full hour on lighting tips. There's a webinar. So after this, feel free to request that video. Or if there's any specific lighting tips that you guys are looking for, shoot those to me, because I want the information in these webinars to benefit you guys and what you want to hear, not what I feel like talking about. So the first thing is basic level tip. This might be some new information for you, or you might zone out right now and go get another cup of coffee because you know all this. But here we go, basic level tip. I want to talk about the F keys. F1 opens up the Micro-Vu help menu. The one thing I will mention is that most all the topics, if not all of them, are covered in the ATI basic and advanced manuals that we wrote and designed for you guys. And they're a little more explained on how to do those tools, how to do those measurements. So if you hit that and you can't find what you want, remember to go back to the ATI basic and advanced manuals. F2 is to rename features, renaming as much and as many features as you can to keep track. So you'll see me today renaming datums, multiple systems, features, and even naming fixtures when I measure a fixture. And it just keeps you in track. So if you're doing parallelism from one plane to another, but you have 5 planes and you don't know which plane 1, 2, 3, 4, or 5 is, if you renamed it top plane, middle plane, lower plane, it helps you stay more organized. F3 is tolerance features. So when you guys write a program, you see if it's in or out. It's a quick way of doing it instead of right-clicking and finding tolerance. F4 is export features. So if you're sending your data to Excel, or if you're doing the Micro-Vu report and using exports, or if you're doing CSV to maybe a ProLink or a, like a data collection software, you want to export everything. One couple more buttons that you might not know of is the F5 starts a new feature type. This is really helpful when you're using more inputs, and I actually want to show you guys this today. I jump over to Inspec. So if I'm going to measure this diameter here, and I do circle, more inputs, and I'm going to use multiple F-scan arcs. So I'll do 1, 2, 3. I'll do another one over here. And I'll do one more arc over here. Now, instead of having to come over and click another circle, I could simply click F5 and it starts a new circle. And then I still have more input selected, so I don't have to click that again. Because remember, a lot of those construction icons, the red icons, they stay on until you turn them off. So now I have my 2 circles. So just a quick little tip that instead of coming over and clicking a new circle or a new line, if you just hit F5, it creates a new same feature that you were just measuring into a new one, so you could do other features on there. F8 returns the machine to load position. if you guys haven't used this before or done this before, clear everything off your stage so the machine can't run into anything, and go ahead and hit F8. You'll see them, if you have a vertex, you'll see the machine go to the lower right-hand corner so you could load more parts on. If you have an Excel, you're going to see the camera go up and all the way to the back of your machine. If you have a sole, I'm sorry, you're the motor, so you have to move the machine to the load position on there. F9, so another thing with the F8 is that at the very end of your program, hit F8 and then the move through button. If you don't know where the move through button is, it's this guy down here. So when you hit F8 and let the machine go to the load position and then hit the move through button, at the end of every single one of your programs, it'll take the last measurement, go to load position, and finish the program and export your data. So then it's open, ready for you to take your fixture parts off and put the next ones on. And F9, if any of you have the Rotary attachment, which I know a lot of you guys do, this turns the Rotary attachment on and off. Why you would want to do that, not sure, but the more reason that I wanted to explain it was if you go to run a Rotary program and the Rotary is not working, you can hit F9 and it'll turn it on. And also, if you go to, I don't have it here right now, but if you go to machine, right underneath this, you'll see enable Rotary or disable Rotary. So if you ever run a program and realize that your Rotary is turned off for some reason, you can hit F9. Another basic level tip is the O-ring tool. I saw a couple requests to hear more about the O-ring tool. So if I come to inspect here, I do file new, we're right here on this washer that I had. So if I click O-ring, so it's over here in the features icon, and then I click the O-ring vision tool icon. One thing that I might hit a snag on is you see all the scratches on my fixture. The O-ring tool might scan that and might go off on that or not be able to measure the O-ring. So first time I'm going to try it without adjusting the lighting, bumping up the lighting a little bit, and then if it fails, we'll go to the other lighting option for you. So I clicked O-ring, I clicked O-ring vision tool. One thing that I've noticed, and this isn't cover all, this isn't the best answer, this isn't going to work for every single O-ring, but I've seen a lot more success if you go just left of 12 o'clock on the O-ring and you click once on the ID, it'll go to the OD, measure the OD, jump to the ID, and then you get your O-ring here. So you get your inner diameter, your outer diameter, and your thickness of your O-ring. I've just seen a lot more repeatability of it being able to complete the O-ring, especially larger O-rings. We have some customers that are measuring 26-inch diameter O-ring gaskets, and the more that you can assist the software in those little tips of going just left of 12 o'clock might make your O-rings more repeatable. So that's that, just a quick little O-ring tool. Intermediate level tip. I want to talk about flipping the part in your program. Instead of having multiple programs for each view of your part, if you're able to measure one side of your part and then use the prompt feature, which is the A with the question mark, and you could put a prompt in your program that says, you know, put post back in fixture and flip over, you know, just instructions that you have. The prompt stops your program until you click OK. So that there's a couple instances that I've seen that you just put a command line in, but not the prompt. The command line will just pop up that PDF or that Word document, but the program will continue. So the nice thing is the A with the question mark stops your program. You can flip your part to the next section that you're going to be measuring. And then when you hit OK, it'll go remeasure the rest of your program, or not remeasure, it'll continue to measure the rest of your program on there. And that's another thing of, you notice in my example right here, I have fixture system, datum B flip, datum B C flip. These are the things that renaming your systems and your datums really helps you out, because if I have two datum A's or datum A, A in one, datum A2, it'll really be confusing later in the program. So that's one thing that I just want to say is that if you're looking to flip your program, or even if you wanted to stop and maybe you have to put a pin in your part, or you have to just whatever you might have to do to stop the program, the A with the question mark, the prompt, stops your program, so you're allowed to do some other things to it, the part, before moving on with your program. All right, before we get to the advanced level tip, I want to talk a couple things about systems before we get there, because it's going to be really important to understand this. If you viewed all of our webinars before, the very first webinar, first or second, I talked about objectives of creating systems and why to set up systems, the point of it, some tips and tricks with it. So one of the things is creating a fully automated or semi-automated program. You can't have a fully automated or semi-automated program without a system, because anything before the system you manually have to do. Anything after the system will be automated on there. Now, if you have a SOL, so a manual machine, same thing. It's not fully automated where the machine's running by itself, but you'll get those arrows and the tools will be remembered. The lighting settings will be remembered to where you move the part, so it's a lot easier for operators, whoever's running the programs. Systems are establishing datums. So if you have a datum structure on your part, on your print, that datum structure needs to be your system. That system needs to be your datum structure. And it also makes more repeatable and accurate programs. Even if your part's moving around a little bit on the stage, well, from one part to the next, as long as you have that system, all the other features follow that on there. Benefits of setting up multiple systems. I mentioned earlier that I would have a fixture system, I would have a part system, and I might even have a specific feature system. And we're going to get into that on my advanced tip. But a couple things just to know is it builds a roadmap for your Micro-V to find your part. So if your fixture might be a little, might move a little bit on your stage from time to time putting it on there, or your part doesn't fit exactly in the fixture that you have, setting a system on your fixture lets the Micro-V know, okay, here's the fixture, now the part should be here. And then when we set a system up on the part, now it knows, all right, the part moved a little bit, but the rest of the program follows that system. It keeps you organized if you do flip the part in the program. Like I mentioned earlier, if you flip the part, setting new systems to your flip datums helps you out there. It promotes repeatability of your program. It accounts for slight differences between parts. So let's say that datum A or datum B is a diameter that kind of moves just slightly a little bit. As long as you set your system to that circle, that diameter, the rest of the program will move with it. Helps programs with fixtures that have some play. I talked about that. And it promotes the ease of getting a semi-automated program running with less steps. So I'm going to do that here, that I'm going to set up a semi-automated program just on my fixture, and then I'm going to set up another system on my part. So all I have to do is just find the corner of the fixture, and then it runs from there. This is nice if you have Vertex on one machine and an Excel on another machine, and you just have one fixture and you have to bring it from one machine to the other for any reason. It just helps out the differences between the two machines, but the program can still run. All right, so let's go ahead and we're going to start measuring some systems to be able to set up for this. What I want to do is translating the table with we might have translated programs in the past of where you measure a whole part and translate that part because you have 10 parts on a stage, or you might have translated one feature linear. I want to talk about the translating with the table function. I rarely use it, but I've seen some applications that I wanted to get out to you guys just in case you have this on your blueprints. So first thing that I'm going to do before we get into that is let's start measuring. And I'm going to be honest, I cheated a little bit so I could find my way around the machine. And I'm going to go to my fixture. All right, I'm going to do File New. So this is the edge of, this is the corner of my acrylic plate that's on my Micro-Vu right now. One thing when you're setting up your systems, if it's a semi-automated program, think of the quickest movements, not while you're programming, but running the part. So if I was going to program this, not thinking what's most efficient, I would come to the corner, hit line, more inputs, measure a line here, move over, measure a line here. So then I'm going to come down over here and measure this edge and do line. I could also hit F5, move down. Now, the thing that is inefficient about this is that I would come up to the corner, I would measure the left line, the first line of this line, and then move to the right. And then I would come down this way and then move up. That's more movements and a lot of travel that you have going on there. So think about when you are starting up your program, what's the quickest movements? So I'd want to come down here on this corner first. And this obviously doesn't apply to every single system that you set up, but think about every system that you set up, how can I make it more efficient so it's easier to get my program up and running? I'll do another line. So now I have my corner here. And I'm going to do a point of intersection between the two. You guys have seen me do this a million times if you viewed the other webinars. I'm going to set my origin to that. I'm going to skew to that top line. Now I'm going to hit F2, and I'm going to rename this my fixture system, so I can keep track of my fixture system. And now I'm going to come over and find my part. And the first part that I'm going to measure today is a circuit board. I saw some comments on registrations that saying you want to know more about electronics. I would love to know more about what electronics you guys would like to see examples of. And I'm always open to taking samples, and I can not explain what the sample is or who it's from or what it's for and just use it for live webinar teachings here. So feel free to send me an email and I can send you the address if you don't have it. And I'd love to use more samples, because another feedback that I got from last year was just more variety of parts. And I'm almost all out of all of our sample parts that I use here. All right, so I'm on my circuit board here. I'll turn the lights on so you guys can see. We got this going on here. We'll see a bunch of different things on this feature, but I'm going to use my profile light. And I'm going to do now, so I found my part, I'm going to do the same thing of less movements on my machine, even though this is automated since I have a system. I'm going to do line, I'll get this edge, and I'm going to come up here and get this edge, more inputs, move over, get that last little bit there. So now I'm going to do a point of intersection between the two. And I'm going to come over here, I'm going to turn on my surface lights. Anything that you guys do in Z, planes, focus points, anything like that, higher magnification gets you more accuracy in Z. So I'm going to do a focus point on my surface. So I'm going to do origin, deselect Z of X and Y to the corner, origin of Z to that focus point, and skew to my part. So now if my fixture moves a little bit, my fixture system corrects anything, any slight offset. And now my part corner system accounts for any variation of the part sitting crooked on the fixture or anything like that. So now I'm going to rename this to part corner system, just to keep myself tracking here. So now I'm going to come over, I'm going to zoom out a little bit. And I want to show you guys the feature first, and then we'll get into our advanced tip. we have this diameter right here. And there's actually, I forgot how many diameters, but on my blueprint, I have something like this on the last page that says it could either be for focus points. So if you're looking for warp in your part, you might have this X and Y location that you have to take a focus point and tolerance your Z from datum A. Or if you have a feature like this where you have a bunch of diameters and on your blueprint, there's a bunch of basic dimensions that tell you where those are. Two things that you can do. You can either manually type it in the translate tolerance, the translate table box, which I'll show you here in a second, or you can type all those basic dimensions into an Excel sheet and copy and paste into there. So I'm going to show you that here in a second. I want to go back to the focus points. One thing to pay attention to with focus points is that if we're taking a focus point and translating it across a plane, you're translating in relation to whatever system you're on. Same thing if I'm going to take a diameter and translate that diameter to a bunch of locations, we're translating in relation to that system. So right now, with how my part's set up, if I was to translate this focus point in relation to my datum, if I put those basic dimensions in, it's going to be from my corner of my part. So one thing that you always want to do is whatever you're translating, if it's one little feature, you want to set your origin to that feature and skew to a straight edge, probably a datum that you have, and you'll translate that feature across whatever basics you have there. The focus point will take a little while because it's going to have to focus on every focus point. What I wanted to show you how you do it is with the circles. So here we have that, we have our basic dimensions that I already put it on an Excel sheet, not to waste your guys' time typing it into an Excel sheet. And then we'll be able to copy and paste it. So what I'm going to do here is I'm going to measure the very first circle. And then I'm going to set my origin to that diameter, set my origin as Z to that focus point and skew to that line. And I'm going to call this my circle system. And then what makes this process a little more repeatable and work for you is that even though we have that circle measured, I want to measure it again. And then I'm going to right click on that circle. I'm going to go to translate. And you have your linear and your grid, which are really good for if you do have features that are exactly the same in X and Y, or if you have a fixture that has multiple parts on it, you know how far apart each part is. But the table over here, so we can actually type in X, Y, and Z locations to where all of our features are. And then you don't have to go find all those features. But if you're able to type them all into an Excel spreadsheet like I did here, we can copy and paste all these features. I'm going to copy, Control C. I'm going to click right here on X and I'm going to Control V, and it pops all of them in there for you. And then I want to make sure that I'm translating with respect to the right system. So another reason why renaming your systems is good, I want to translate in relation to my circle system. And I'm going to click OK. And you can see all of them there. You right click and it goes and it measures all of them because they're in the location, the basic dimensions that told us. And you guys might be asking, why am I using surface light and not profile light since I can see through that hole? On this fixture, we have a bunch of through holes on it that there's kind of blocking some of those diameters there. And that's something that's a little frustrating sometimes with some fixtures, is that even though profile light will be the best for a through hole, it's not always the best there for you. One thing I want to mention that you should do before translating is you should hit F2, rename it to circle 1. You should hit F3. You should tolerance it. And then you should hit F4 and export it. Because when you translate it, it's going to carry that tolerance and that export, so you don't have to go and tolerance and export every single diameter that you have on there. I can right click, remeasure on there. So, you know, if you have one diameter that is translated across your part so many times, this is really good. Focus points, it's really good. Let's go ahead and just try that out just to show you guys focus points. So I'm going to set my origin of X, Y, and Z to that focus point, skew to that line. I'm going to zoom in and take a new focus point. And you could do the same thing if we have translate, table, and then so if you have something like this on the back of your print, probably the last page, I say that because generally that's where I see it, or if it's one page, it's probably in one of the corners. If you guys see one of these boxes that say take a focus point or a point in Z in all these locations, then you can go and you can just type those in to your table translating, and it'll go take all those focus points for you. So it's just quicker ways of getting a lot of data instead of you moving around and trying to find all those points or right clicking in the camera window. You know, instead of doing this of move to absolute, you know, 9.5, and let's say 5.5. No idea where this is going to take me. Moves over a little bit, it's off the part, but your blueprint would tell you where to go on those kind of things. So it's just a quicker way of doing those things. How did you make, I got a question here in the chat box, how did you make the different dimensions appear as features again? Of all the different circle, all these circles here, let me know if that's what you're talking about, all those different circle 1, 2, 3, 4 on there, the multiple circles. So what I did, just to go over it one more time in case you guys didn't catch it, is I right click on that circle, and since I renamed it to circle 1, when I translate it, it takes that circle 1 and it goes to the next number on there when you translate it. So as soon as I click OK, it generates all those circles, but you notice that they're gray because they're not measured yet. So what I got to do is I got to right click, remeasure, and it'll go get all those circles on there. If that doesn't answer your question, shoot Dan and Dustin at atiquality.com, both of us an email. And if you have an application that you're looking to use this, let us help you out on that one. So that was a quick lesson on translating with the table function. If you guys have parts that you realize this could be really useful for, but you're not sure how to take what I just explained to actually apply it to your part, again, email us. We'd love to help you out and make sure that you guys are getting the most out of your machine on there. One little thing that I want to throw in there was just for fun tip. This here, if you're using the Micro-Vu reports, when you go to your company info, so if you go to the tools drop-down menu, change company info, you can fill out your company info. And one thing that always gets me is I always want there to be a change photo button, but if you right click on that image not found and say change source, you're able to change the picture to your company logo on there. So then your Micro-Vu reports look even more professional. You can send them to customers, send them to your boss, engineering, whatever might be needed, and you could do that. So that was just a little thing in there. All right, so focus point trick. This is another thing. Instead of trying to find all the points for a plane on the top of a surface, something that will be able to help you program faster and finding those, because when you're at a high magnification, finding small features at 100x is really difficult. So, but finding it at 25 or 35x is a lot more simple. So here's just a list of this. I am able to send you this PowerPoint after the webinar. When I send you a follow-up email with a survey, you can request this just to give you the steps. But I'm going to show you in real time how to do this. And I'm going to cheat again, open up this. I'm going to move here. All right, so I got this part over here that as I move around slowly, you could see, get some better lighting for my surface here. All right, so I'm going to move around this part a little bit. You can see that surface that I focused on. It's really small guard bands and moving around trying to find all this. But let's say that that whole surface is datum A. If I came over here, I find the end of my part here, and if I zoomed in, when I start moving, trying to find my next surface might be difficult, or you can randomly just hit the points. But one way to make it quicker is if we come over, find this edge. I'm going to do plane, more inputs. I'm going to do a focus point. I'm going to take a point there. I'm at a low mag, which is not good practice to do. You want to be at high magnification when you are taking anything in Z. But when we set new lights and zoom for this, and see, it's easier just to move the machine around at a low magnification, find our points. And let's say this is our last point that we're going to take. Now I'm going to move up to a higher magnification, reset my lights, retake my focus point. Now I only did the magnification on this one focus point and adjusted my lights just on this one focus point. But if I right click this and I say set lights and zoom, and I remeasure, oh, I didn't have a system. Let's do that one. Actually, I'm going to throw in a recall refsys. Here's another little thing if you didn't know. You can right click on a feature, insert here, and it'll put it on top of that feature, and you start writing your program in there. So if you miss a feature, you can right click, insert here. And I'm going to right click that plane and say set system to system 2, insert at end. And now, so now you see I'm at 95x and my lighting settings there. And I'll go over that one more time for you guys. But instead of having to, find the part at a high magnification, moving around, not finding the part, moving past it really quick because, it's really zoomed in. If we do low mag, I'll recall refsys so it's automated. And we do plane, more inputs, and we take our focus points across the stage or across the part. Because sometimes on your blueprints, it says that datum A needs to be measured at these specific locations. And at high magnification, it's hard to find those specific locations. I'll do one more over here. And we'll go to high magnification, update our focus point, right click, set lights and zoom, and then go ahead and remeasure. And now it's at the high magnification on there. That trick and that tool that I just used of setting lights and zoom, if you do have an offline seat, you'll use that a lot, taking a DXF from your offline seat program and actually putting it on your Micro-Vu on there. All right, here's another thing, Z measurement trick. I've seen this a lot on plastic parts that have clips where you need to measure from the bottom of a clip to the top surface, or you have multiple steps down into a diameter. Anything that you're doing, a Z height, like a plane from one plane to the other, or anything height since we're looking down on the part. One thing, a little trick that I like to do, go find my plastic part. All right. So if you have something like this on your blueprint where it's one height to the next, here's an example of, in my top left picture, I want to get if that's datum A, and I need to get two different heights on tabs. So if you look at my top right picture, that's 2 millimeters up on my blueprint. And then the other one here is 1¼ millimeters above datum Z. So there's two ways to do it. I'll show you with a system setup and without a system setup. Is that if we come over here and I zoom in, because we want to do everything in Z at a high magnification. Now you might be wondering, why don't I do the low mag and then set lights and zoom? I can't do that because all the focus points are at different Z heights. You only can use that when it's at the same Z height. So I'm going to go ahead and do this without a system setup. So if I'm just doing, if this isn't datum A, I'm going to take a focus point here. But on my blueprint, I know from this surface to the next surface is 2 millimeters. I'm going to right click in the camera window, move to, I'm going to use relative, not absolute, because absolute, since I don't have a system set up, is from my machine 00, my machine coordinate system. So I'm going to do relative. I'm going to move up in Z 2 millimeters. So now when I move over to find my feature, I know what feature, what surface I'm looking for. Now, if I didn't do that, the frustrating part is, to come back down here, is when we move over and we're at a high magnification, sometimes you don't know if you're supposed to go down or up in your zoom just because you're like really focused in on the camera, and how quickly, if you're moving, how quickly it goes out of focus. But if we're down here, another dangerous thing about hitting focus points, if you don't hit a surface, it starts searching for you. So we go back to my original focus point, and I right click, move to, up in Z, 2 millimeters. Now I know I'm at my height that I'm supposed to. Take that. And then my next one, move to, I believe this is down, not that, a little more. There you go. And you'd be able to do that. So setting with a system, let's go back to my first focus point. If we set our origin of Z to that point, and then now if we do a new focus point, we can use move absolute 2 millimeters because we know how far it is because that's from datum A. And then on this other feature, I know it is negative 1.2 from datum A. So then I hit it and it's there. Just a quick little thing. Instead of, trying to move your Z up, it may take you a little longer one way or the other, but try it out. And sometimes you'll see that it does run quicker when you're using the right click, move to wherever your heights are in Z on there. The last thing that I wanted to hit in this webinar before we get to the Q&A is flip working planes. Important steps is setting up proper systems, making sure that you have your origin X and Y, your origin of Z, and then keeping track. So the renaming of keeping track of where what systems are what systems is really important. Also, knowing the difference between YZ and XZ, and I'll show you that, but think about it this way, that when we flip a working plane, if you flip it to YZ, think about the camera looking from the right side or the left side of the machine. and that's how it's looking. You're tricking the software that it's looking at from it that way. If you're an XZ, it's looking from the front of the machine on there. Keeping track of that. I've seen customers write it down on their machine on a sticker. If you ever go to a quality show or a trade show, sometimes they have little foam pieces that are X, Y, and Z, so you can, have it at your desk. And if we're ever training in person, I'll show you a trick with your hand of holding it out and remembering what X, Y, and Z is on there. Another things that I wanted to mention was flip working planes with vision. I really want you to feel like you're at an intermediate level before doing it. In a program, especially if you have touch probe, I want you to really be comfortable doing it with vision and at that advanced level, because you could be throwing off some move through points with your probe on there. And if you're nervous about doing it or not sure if it's the right application, ask help from us. So let's go ahead and actually do the flip working plane, and I'll show you why we want to flip the working plane. Might go a little over here today, but hopefully that's all right with you guys. If not, feel free to jump off, and if you got to get back to work, and I'll send you the recording, but we'll finish up maybe 5-10 minutes after 11 o'clock here. So I'm going to set up a proper system on here. I could probably spend a little more time with my lighting, but for time's sake, I'm going to go ahead and take this edge, come up here and take this edge. Probably do a little better with my focus, and then I'm going to come over and take a focus point on this surface here. All right, so I'm going to do an intersection point between those two edges. Then my origin of X and Y to that corner, origin of Z to that focus point. I'm going to skew to this edge. And I'm going to hit PCS view. If you don't know what PCS view is it moves your schematic window to align with your origin and skew. And this will be really important when we're flip working planes. So now I'm going to rename that to XYZ system to keep track. And then I'm going to come over, and we got this radius here. I believe I have a picture right here. So I want to take this radius right here, but the camera is looking straight down in Z, so the orange. So we want to find the YZ flip working plane so it looks like it's looking in this direction. So if we zoom in, and I'm going to show you why we need to flip working planes and why it won't work if we're just in the regular system. So I'm going to do a bunch of focus points. Now we want that radius, we want that arc, but before we flip the working plane, I want to just use focus points so we can construct with it later. So I'm going to go down this radius here, take a bunch of focus points. All right, that should be enough there. So I am in my X, Y, and Z system. So it's the normal, we could call it the normal machine system, whatever you want to do. And if I do, I'm going to show you guys, so I'm going to do the right view. So we can see we have an arc right here. But if I do arc, more inputs, and I select all those, it does a straight line because it thinks, because the software and the camera is thinking it's more 2D because we're in the XY plane, it's just going to see the straight line. Even though those points have Z values, it's only using the X and Y values to create that straight arc. And our radius is 144 millimeters. Now I'm going to hit that again. I'm going to hit the PCS view. Now if I click this system feature icon and I click my XYZ system, so I copy it, and then I come down to flip working plane, you notice down here in my inputs it says YZ. And if you click it again, it's an XZ. And if you click it again, it's back to whatever it normally was. So I'm going to click it once. Now I'm in YZ. I'm going to rename this to YZ system. And when we hit the PCS view, Now the part coordinate system view it's the direction and the features that the way we want to look at it. So now if I hit arc, more inputs, and I select my focus points, now it actually sees those Z values and where it is and why. So we actually get our radius on here. Now, if we go to take another measurement that's not in the YZ plane and we need to be back in the XY plane, we can just click System, copy our XYZ system, and now when we hit PCS, we're back into that view of it. So it's really important of switching back and forth and always getting back to your XY plane. So when you're measuring any other features, especially with a touch probe, it knows that it's in the right plane that it's looking at. So that's one of the things, is just always getting back to the XY system, because it's easy to get lost and forget that you're in one of the flip working planes on there. So before we get to the Q&A, which will be in 1 minute here, I just want to say again, if you guys have any needs for custom fixtures or anything for your parts, contact us. We'd love to help you out. We design, build, and program the fixtures for you, so your operators or even you as a programmer can just click run and it's done for you. So if you guys are really busy or have stuff coming down the pipeline, let us know. Again, if you guys have any inspection projects that you guys need to send us, we're offering 15% off for projects over $250. Send us blueprints and quantities. We'd love to help you out. Tons of also metrology training that's out there. In case you guys didn't know, we do blueprint reading, we do GD&T. Any training that your team needs, contact us, and we'd love to make a custom class for you. Just a couple other training webinars that are out there. Again, if you guys are looking for any training, let us know. I'm going to go ahead and jump over to Q&A. Jump in the chat box if you guys have any questions or want me to do any of the examples over again. Feel free to pop it in there. If I can't do a live version of a question that you have, we can jump on a team viewer afterwards, or email would be great. So thanks again for joining today. If you guys have any questions, comments, anything, pop them in the chat box. I will be sending an email here shortly with a follow-up of a lunch and learn opportunity for you guys, survey that I would love for you guys to fill out just to make these webinars better for you guys. And then you can also respond to that for any questions you have as well. So we'll be on here for a little while longer. I don't see any questions right now, but go ahead and pop them in there if you do. Thanks, Mark. What is the purpose of making the move to... I'll let you finish that one, Christina. I do that on Teams Messenger all the time, is hit enter and it sends half the message. Thank you, Richard. Appreciate that. I appreciate all the things. Christina asks, what is the purpose of making the move to on the Z plane? I don't understand what it does for program, or is it just convenience? Yeah, it's just convenience when you're working, especially if it's higher than 2 millimeters. I just use that example because it's a quick little move up. But when I'm on that, and feel free while I'm answering this question to pop your other questions in there and we'll get to them. But if I go over to my piece again, I'll show you why I use it, and this might help you out. So when I'm really zoomed in, let's go even more dramatic. I'm searching in Z, it's so easy to like pass by that focus real quick. So if I take a focus point, file new, so I'll do a focus point. I know that this next feature, because my blueprint says is 2 millimeters up, and because I'm moving slow, it's easy, but if you move fast, you kind of move past it real quick. So if I know if I'm at this focus point, and I know that my next feature is up in 2 millimeters, it's just a quicker way of moving over. And the faster you get with right click, move to, and type in your Z, since it's on your blueprint, it's just there. So yeah, it's just more of a convenience thing. It's those little things that we learn over programming and training with customers that I really like to get out in these webinars. So not just one company, or we're holding the information to ourselves. So hopefully that answered it. But yes, it's more of a convenience thing. When you do heights, see if it works for you, and if it's not as quick or is not convenient for you, don't use it and just go up in Z on there. So more preference thing there. Have you tried to put a focal point before a hole and Z to the point and then copy to the grid? Let me read that one more time. Right off, Joe, to your question, I might not be imagining what you're asking real quick, but I know we've been chatting a little bit. I believe so. Send me an email, and I'd love to talk more about that, because if that's another tips and tricks that I can add into a future webinar, I'd like to share it with everybody. Or if it's just something that you came up with right now, let's explore it and see if it's something. So go ahead and send Dustin at ATI and Dan at ATI an email. Oh, so like going to that focus. So in case that diameter is moving a little bit in the Z, you're setting an origin in Z next to the diameter. I have done that before if I have plastic parts that vary a little bit, especially from cavity to cavity, or maybe even thickness of the part, where if you move over and you set a new origin of Z to a focus point next to a diameter, it helps move your program along. So yes, I have done something like that, where the more Z origins that I have, the better, especially in plastic or flimsy parts that aren't really solid, because then it follows your program along and resets Z origins to account for any part variations on there. So if we did, now the one thing to be careful about that is, it just came to mind, is that if you translate a diameter with that Z origin, it's going to translate in that Z origin. Yeah, so that Z, so if I set a Z, let's go to it real quick. Come over to my board. Actually, that's a really good question, Joe. If you can translate the system, and if it resets the system to the next one. Before I accidentally crash my machine, I'm going to do a trial on my Excel with everything off the stage, because I got a bunch of fixtures on here. If you translate the system, if that next circle, so what I'm explaining there, let me just go ahead and do it. I'll take the other pieces off. So if we do focus point, I'm going to do a recall refs, make it automated. So I'm going to do a focus point. Oh, I should have been more focused in. Oh, it'll get it. So I'll do a focus point, and then I will do a circle on here, and I'm hoping this is what you're asking there. Ignore that focus point. I shouldn't have clicked. So I'll do an F-scan circle around that diameter. So I'm going to set my origin of XY to that circle. I'm going to set my origin of Z to that point. And then if I do that, right click, translate. So if we look at this, if we do, I mean, that's a lot of focus points of zooming in and out, but I get your point. So that's looking at system 1. So because I translated within respect to system 1, everything's looking at system 1. It's not looking at that new focus point. But I'm going to write that down and see if there's a variation that we can make that work for you. Maybe if we take all the focus points first and then reset systems on there, because like if this part warped at all, those focus points would help making sure those diameters are in focus on there, but they all look to the system that we translated in respect to. So let me see if there's a little trick there that I can work up to make that work for you. And if anybody listening or watching right now that doesn't know what we're talking about, feel free, if I get this figured out, feel free to email me and I'll maybe do a little recording on my machine of what I did there. Thanks, Joe. We'll stick on for a few more minutes here. Did I miss any questions while I was doing that? Awesome. Thanks everybody for sticking around. If there's no more questions, also feel free to shoot us an email and we'll see you on the next webinar.